So hello everyone. So in the previous sessions I have discussed about the powder X-ray diffraction techniques and the powder photographic methods. So in this session, so I will be discussing with the single crystal X-ray diffractometer. So as I mentioned in the previous session, so the X-ray diffraction mainly has two different types of registering X-rays, that is mainly based on the samples handled. There are two types. So one is powder X-ray method and the other one is the single crystal method. So here in single crystal method, the sample is a whole specimen, it is a single crystal, so without any discontinuity. The single crystal is used for the determination of its structure or unit cell parameters. So it is not like the PXRD. In powder XR diffraction, so it is the crystallites. The sample is, the crystals are homogenized, but here it is a single crystal of definite shape and size, so which is used for the study. And for the study of these single crystals, so especially this particular instrument is used. This is image of Bruker Kappa Apex 2 instrument. So it is a single crystal X-ray diffractometer, and this is the host computer here. Let us look at the components of this diffractometer, and this is X-ray generation tube, and here you have the microscope, and this is the cryostat, and here we have the detector, and this is the goniometer base, and here this is exactly at the center the sample holder. So this is the goniometer head, it is also called as goniometer head or the sample holder, so where exactly the sample is placed. So this instrument, it is also called as 4-circle goniometer because it produces, it facilitates 4 different types of rotations. So there is a rotation for the detector, there is a rotation for the sample, and there is a rotation for the goniometer head, and there is a rotation for the goniometer base. So let us see the components one by one. So let us see first these angles. So the rotation of the goniometer base is called omega rotation, and the rotation of the goniometer head, that is phi rotation, and that rotates the sample. And here the goniometer base, that is omega rotation, rotates both it rotates the goniometer head. And the detector, the rotation of the detector is 2 theta, and the kappa rotation, so it is a swinging motion of this particular arm. So if you look at this arm, so where exactly this goniometer head is placed, so swinging action. So in case of 3-circle goniometer, so this kappa axis, this kappa arm or kappa axis is placed exactly at 45 degrees. And in 4-circle goniometer, so which is rotates, so plus 90 degrees to minus 90 degrees. And of course it contains a beam trapper along with the detector. So as I mentioned the different components, let us see one by one. The X-ray generation tube, so usually electric field of about 30 kilowatts, so it is volts is used, and the metal targets usually the copper, so which produces copper K alpha radiation of wavelength lambda is equal to 1.54 angstroms, or sometimes the molybdenum is used, so with the suitable metal filters. And the next is goniometer system, that is I have already explained it in the PXRD. It holds the sample, that is goniometer head, and the detector, and crystal mounting. So here the crystal is mounted on the goniometer head. So the goniometer head is made up of brass pin, and so it is connected to a fiber, glass fiber. So at the tip of the glass fiber, the sample, the single crystal is placed, and with the help of wax, and this crystal is aligned exactly at the center of this instrument using a microscope. So this microscope facilitates to set up this crystal exactly at the center of the goniometer system, and so that the incoming X-rays from the X-ray generation tube falls on the, it ensures the incoming X-rays from the X-ray generation tube, so which falls on the crystal which is placed at the goniometer head. Say it is video camera or the microscope, so which is helpful for the aligning the specimen or the sample or the crystal and also indexing the crystal faces. So one can rotate the crystal goniometer head and look at the different faces of that crystal to get the reflections from different faces. So usually the shiny face, the well polished shiny face is exposed to the incident beam. So that is made with the help of this video camera or the microscope. And the role of the cryostat is to reduce the temperature, because the crystal which is placed at the goniometer head, that is continuously exposed to the X-rays. So there will be a increase in the temperature on the crystal surface. There will be increase in the crystal surface that affects the intensity. So that's why there is a cryostat, so which is used to reduce the temperature on the surface of the crystal. So due to the exposure, due to exposure to the X-rays, incoming X-rays. And next is X-ray detector system. So as I already said, so it make use of counter devices, that is especially these single crystal X-ray diffractometer uses CCD, charge coupled detectors, microprocessor chips for detecting the reflections. The reflections are recorded by this CCD, charge coupled detectors. Earlier CAD, computer assisted detectors were used. So now the advanced instruments make use of CCDs, that is microprocessor based chips, and this after detection it will be amplified, and there is a microprocessor based interference module, so that exhibit a connection between the instrument with the host computer. So the rotation of the detectors and closing of the doors, the shutters, so of this instrumental setup, and the placement of the crystal, rotation of the crystals. So all these actions were controlled using a microprocessor interference module. So that connects the instrument with the host computer, and the host computer, so it comes with the packages, software packages, so where the reflections, so which is recorded in the detector, so that is processed to get a diffractogram. So in the host computer, not only the reflections are processed, or the data, raw data is processed, also it is used to control the instrument, the rotations, the various rotations in the goniometer and the sample placement. So all this can be monitored by using host computer. And now let us look at the advantages of this method. The main advantage of this single crystal X-ray diffractometer is this allows the crystal in any desired orientation. It keeps the crystal in any desired orientation. So we can keep the crystals in any desired orientation, so that all the faces of the crystal is exposed to the X-rays. And it also helps to bring the desired reflecting planes to the correct diffraction angle or the glancing angle with the incident beam, and rotate the reflecting planes so that the scattering vector is horizontal. So rotation of the reflecting planes, and also the rotation of the detector arm, and to position it in angle equal to twice the glancing angle. The detector angle is always twice the glancing angle. So all these are the advantages of this single crystal X-ray diffractometer. So one can use it for the determination of to know the determination of the crystal structures. So it finds applications similar to PXRD in various fields. Thank you.